is from our lovely radicals unit, which would be unit 7. Anybody remember how to do the first problem? Can I add those together? Not like it is, right? Can you break down 24 under a cube root? What's the biggest perfect cube that goes into 24? 8, right? So, all right, let me just, here, I'll just kind of write it to the side. I didn't do a good job putting a lot of work. So 24 is 8 times 3, right? What is the cube root of 8? And you guys, we might need to grab those little yellow cards out if we don't remember. I got them up on the board too on the side. So cube root of 8 is 2. How do I handle that with the 5 that's already in front there? Like, what do you do with the 2 and the 5? You multiply them. Okay, so really, this is 20 cube roots of 3 plus 10 cube roots of 3. Now can we add them together? Okay, now don't change what's under the radical, right? Just literally, it's like 20x plus 10x. You just keep the radical 3. This would be 30 cube roots of 3. That would be my answer there. So it didn't look like we could add it initially, but we actually can. Okay, now this guy's a little bit more recent. This is from our rationals unit. We have 2 over x minus 1 squared plus 2 to the side. What value can x not be here? 1, right? Whatever, we can't divide by 0. So it's the opposite of what that looks like. So positive 1, that's going to be your vertical lovely asymptote here. So x equals 1. Okay, do I have a horizontal asymptote here? Like, are we going to shift up or down? And how much? What do you think? Up 2. Whatever this is, you're just going to copy that. That's the y. So opposite with the x, outside the operation there. So in this case, outside that fraction, we're going to have the y. So y would be 2. Those are your 2 asymptotes there. It does say we're going to graph this and then state the domain and range. Okay, now what I want to be really mindful of here is this is squared. So if the you don't have to FOIL it or anything like that, but you just got to remember, if it's squared, both branches are going to go the same direction. They're either both going to go up or they're both going to go down. Does anybody know how to tell me, like, should both branches go up above those asymptotes or should they go below? Like, how do I know? Why? It's positive 2. That's the key to that. Okay, if this is positive, they're both going to go up. If that was a negative 2, then the branches would both go down. So we're just going to sketch this because you guys are going to pick these out of multiple choice. They don't have to be graphed perfectly or anything like that. Oh my goodness. Don't look at my paper right now. These 2 branches. All right, squared. They have to go the same way. So the 2 branches would be above there. Now, to do your domain for all of these, you're going left and right forever. So you do cover every value except that value that would cause you to divide by 0. Should be right between the branches, the vertical asymptote. So this is all real numbers, but x is not allowed to be 1. If you guys, let me just write this real quick so you have it. In interval notation, the way you would do that, you would go negative infinity, comma 1, and it would be a parenthesis, and then we'd have a little union symbol, 1 to positive infinity. You're basically excluding 1 in the interval notation by writing it in that format. But I would take either one of those and I'll write both of them in the multiple choice for you. Okay, now for your range here, this is not like in all real numbers except 1 because I don't touch any part of the graph till I hop over that asymptote. So all the y values are going to be above 2, but we're not actually going to touch the 2. So you would just write 2 comma positive infinity for your range there. Anybody have a question? Okay. For number 3, these are all kind of mixed together. This is back to radicals. This says rationalize the denominator and simplify if we can. So I have a square root here. I have negative 9, and then underneath I have the square root of 6x squared. What do you want to multiply by here to rationalize the denominator? Because I'm not allowed to have a radical in the bottom. Totally fine to have a radical in the top. What would you multiply by here? Or what am I going to try to get? Okay, I got to try and turn 6 into a perfect square. What would you multiply 6 by to make it a perfect square? 6, thank you. Okay, I'm about to have a heart attack. Okay, now, the variable there is x to the third. Is that a perfect square? No, okay. How do I get a perfect square with a variable? Like, what do I need? We just need an x here. You need your exponent to be divisible by 2. So to get that to happen here, if I multiply by another x, that'll create x to the fourth. If it's an even exponent under a square root, it is going to be a perfect square. Okay, now whatever I multiply by the bottom to get that perfect square, I got to do the same thing to the top. This is really, and you don't have to write this, but I'm multiplying by 1 here. That's equal to 1. It's not changing the value of the expression to multiply by 1. That's why this is legal. Now, across the top, we're going to do -9 square root 6x. We can't put those together because the -9 was not under a radical. The bottom here becomes square root 6 times 6 is 36, and then x cubed times x would give us x to the fourth. And to get rid of a radical under a square root, you just need an even exponent on your variable. So then, let's see, the bottom of this would just become 6, and this would become x squared. You just divide your exponent by the index of the root, which here would be 2 because we got a square root. So I have -9 roots of 6x over 6x squared. And then I'm just going to ask you before we say that's our answer, can I simplify anything else in this fraction? You can, okay, yeah. Don't touch what's under the radical. Everything's being multiplied here, but both of those numbers are divisible by 3. So you can reduce this. This would be -3. Don't change what's under the radical. That's still going to be 6x. The bottom here would be 2x squared. Nothing else can be done at that point. Does anybody have a question? Okay, now number 4, this is an exponential equation, right? This is a true statement. It just asks us to write it in log form. So all that means is we're going to introduce a log. So if you guys remember, we're just going to take base of our exponent. I'm going to drag this over to the other side. That becomes the base of the log. So when I drag this over, the 5/2, that exponent comes down on the level with the rest of the question. And then the base of my exponent is now going to be the base or the little subscript for the log. So it'd be log base 25. You introduce a log to cancel out an exponential. And you can just kind of scooch that 3125 to the side there. So it'd be log base 25. We're not solving anything here. I don't have a variable. We're just converting between the two formats. That's literally it. This is also a true statement. Okay, now we're going to have formulas for you guys on these problems. So let me write the one for this. I see compounded continuously. So we haven't done this for a minute. This is from our logs and exponentials unit. Amount in your account, if you're compounded continuously, it's your principal and then e, not a variable, the number e. And then the exponent is the rate multiplied by the time. Call that the little PERT formula. You want to use that if you see compounded continuously. All right, now all we're going to do is plug numbers into that equation from that description, and you guys are going to do that while I go figure out where my calculator is. So go ahead and look and see if you can plug that in. It says how much money invested at 7% compounded continuously for 10 years will yield. So you're going to have $7,000 in the account at the end. We're going to solve for the principal here. So hopefully that was your variable, right? Because we are going to have $7,000 in this account. E, what should I put in for the R? 0.07. Don't put a 1 in front of it. I think sometimes people get tripped up with that. It's just straight up the rate, but you do have to put it as a decimal. And then the time is 10 years. So we're going to solve for the principal here. How would you do that? Like, how would I get P by itself? You can do this whole problem on your calculator. What would you do to get P by itself? Yeah, you're gonna, or not, we're not gonna divide by 7,000. What am I gonna divide by? I'm gonna divide the 7,000, yeah. Okay, divide that. Okay, now let me, if you wanna simplify the exponent, maybe so you don't have to push so many buttons in the calculator, you could maybe do that. This would be 7,000 PE, this would be the 0.7 power. So all you have to do in your calculator, you're gonna do 7,000 divided by e to that 0.7 power. Now I'm just going to remind you where that's at. So 7,000 divided by, now your e button, to get it, you have to hit a second. And if you have a scientific calculator, it's probably the same thing, but in a different spot. If that natural log button is by the 4, e to the x is the second function for that. So just hit second and that natural log button, and I'm not on the screen, sorry. And then you can just type the 0.7. And this will give us our answer. Now, we're talking about money in this question, so I should round to 2 decimal places. So we're going to say, let's see, $3,476.10 if I round to the nearest tenth there. That would have been the investment. All right, now my next one is a several part question. So this is from our probability unit. And it says a survey was done of commuters in 3 major cities about how they primarily got to work. And then we have the results. So really the data is here. And then they give you the totals for each column and each row. All right, now this just says we're going to find the probability. We just randomly pick somebody from this group and they are from New York. How would you set up a probability to figure out, just I randomly pick somebody from this table, they're from New York? That's the only requirement. What would you put together? Eli, what do you think? Perfect. Okay, there's 80 total people from New York. There's 200 total people in this table. So just be 80 over 200, and it totally does not tell us how it wants us to write the answer. So I will figure that out and tell you. If you want to reduce this, this is 2/5. As a percentage, it would be a 40% chance. As a decimal, it would be 0.4. I will find out and let you guys know what format it gives you the multiple choice on the test so you can know. All right, how would I do the second question? So this is the probability the person is both from LA and they use a car to get to work. If I have a table, you don't have to do a ton to do this question, but what's the probability I'd randomly pick somebody, LA, and they drive a car? Exactly. You're just going to find this intersection. So LA and they drive a car. Here's your car column. Here's your LA row. So there's 36 people that fit both of those categories. You're just finding that intersection. So that's all we would do. Just 36 out of 200 total. The 36 is the intersection of those two. So as a fraction, this reduces to 9 over 50. And it would be as a decimal 0.18, or as a percentage 18% chance I would pick. So I'm just going to write all three. Okay, now this one can be tricky. How would I figure out if I would randomly pick somebody, they're from LA or they drive a car to work? How would I figure that out? Go ahead. 70. Okay, so what does the 70 represent? Perfect. Okay, so we need those people. Okay, so 70. We don't want to put this over 200 quite yet. Or this could be part of it. So 70 out of 200 are from LA, right? Go ahead. Okay, so then you have 62 people out of 200 that are driving a car. Now, do I need to do anything else with that? Yeah. Yes. Okay, so we basically counted a group of people twice. So the 70 and the 62, we counted these 36 people. We counted them in both of those categories because they were both in that column and that row. So we have to subtract off the 36 over 200. Now, all of these guys obviously are going to have common denominator here. So we're just doing 70 plus 62 minus our 36 overlap, and I'm not on the screen, forgive. So total here would be 96 out of 200 then. So if I want to do a fraction that's reduced, this would be 12 out of 25, and it's 0.48 as a decimal, or 48%. Okay, now these last three are all given or conditional probabilities here, and I'm just going to write one of them, but this was the one, I just wrote out the word given, but this is probability I grab somebody that rides to work in a train given, that was the one where we had that like vertical bar, given that I know the person is from New York. If you have a given statement, you're just going to look at either that column or that row, whatever they give you. So given, I know the person I picked here is from New York. So I would literally only look at that top row. Given that I picked the person from New York, what's the probability they ride a train to work? How would you set that one up? What do you think? 50 over 80, perfect. You just work with that column or that row. So this would be 5/8. Now, what's the probability the person drives or rides the train to work if you know that they are from Chicago? Like, how would I set that one up? So given they're from Chicago, they take the train to work. What would that fraction be? Say that to me one more time. Yes, perfect. I don't know if that is reduced. Let me look. All right, so we got 14 over 25 for that one. All right, now this one's a little different. Given that you know the person rides the train to work, what's the probability they're from Chicago? So it's like reverse of what we just did, but the probabilities are not going to be the same. So what's the probability? I know I grabbed somebody from the train, or that takes the train. What's the probability that they're from Chicago? Exactly, 28 over 102. If you have a given, whatever that's given to you, we're going to use that total in either that column or that row. So 28 out of 102, and this is going to reduce to 14 over 51. Does anybody have a question? All right. Let's sketch a couple of graphs here. Okay. So I'm going to write a little note on this so you guys can hopefully remember this. Anytime you have a log function, always has the point 1, 0, and whatever the base is, in this case the base is 2, 1. All right, that would be before any shifting or anything would take place. Now I do have some shifting on this graph. So with the x, we're going to go the opposite of what that looks like. So that looks like -3 to me, so it's actually +3. All right, so we have a nice vertexal asymptote here. This would be x equals 3. And then the y, we're going to shift up 2. So if I wanted to describe this, this is going right 3 and up 2 versus if we just had the plain log base 2 of x. So that 3 with the x shifts it left or right, opposite way you think, and then the outside goes up or down, and you're just going to copy that. Okay, now I'm drawing this horizontal line in here. That is not an asymptote for this graph though. If you want to use what I just told you, we did this shift. We went to the right 3 and we went up 2. Just pretend this is your new x and y axis. So for this graph, they would have the point 1, 0 and 2, 1 before we do any kind of a shift. If you want to just pretend that's the x and y axis, this would be the point 1, 0. So on our actual graph, that would correspond to the point 4, 2. And this would be the point 2, 1, which would actually correspond to the point 5, 3 if you wanted to do that. And we're just going to kind of do a sketch. So the general shape of a log function looks like that. And what you got to remember here, you can't take the log of a negative number, so that's why that has that vertical asymptote. Because if I plugged in like 2 for x, that would cause us to take a log of a negative number, so that's not defined. All right, so let me write down these guys here for you too. Now your domain, you cannot take the log of a negative number, so we're not touching any part of this graph until we get on the right side of that 3. So you don't actually touch 3, because if we plugged in 3, we'd take the log of a negative number. So they're going to use a parenthesis there. So it just goes 3 to infinity. And then your range for any log, it's a function. This is going down forever. It's just not going to go over this asymptote. This is going, it does not level out. It's gradually going to the right and up forever. So it should just be negative infinity to infinity for your range. And the asymptote is the x equals 3. Anytime you have a log function, it has a vertical asymptote. So vertexal, if you want to remember that. All right. Now the next one, this is a cube root graph. All right, so general shape of a cube root. See if you remember this. Goes up, like swings up to the right, and then swings back like that. So this would just be y equals the cube root of x. Let me draw you just one more picture just real quick. This is not going to be for this particular question, but if you have, I'm going to flip that. If you have a negative cube root of x, it looks like that one. This one's positive. I don't have a negative in front of this. So this should go like that first picture I drew there. Now, all you have to do is use the numbers in the radical and outside the radical to shift that middle point. So this works with your opposite copy. So this is going to be -2, -3. Now, that will be directly in the center of that. The reason is you can take the cube root of a positive number or a negative number. So this, if I plug in -2, that causes me to take square root of 0. We can do that. But then all these guys going this way would be taking the square root of a positive number. And these are going to be flipped back. All these guys would be taking the square root of a negative number if we plugged in the x value. When you have a plain square root, you can't do the square root of a negative number, but you can do the cube root. So that's why that swings both directions. And again, you guys, these will be probably a little easier on the test because they're going to be multiple choice. You're just going to have to pick the graph out. No asymptotes or anything. Domain and range here, this is just like a line. This negative infinity to infinity, left and right forever. Range, same thing. It goes really gradually, but it does go up and down forever as well. So just negative infinity to infinity for both domain and range. Okay, we're going to swing back into our probability unit here. It says number cubed, so like think of dice. What's the probability of rolling a 3 or a number less than 4? All right, so I can roll a 3. And then it says a number less than 4. So on like a number cube or dice, think about that. Numbers less than 4 would be 1, 2, 3. Would you include 4? No, because it doesn't say less than or equal to. It just says strictly less than. Okay, now I want to see here how many of these are different, because the 3 falls into both of those categories. You don't want to count that twice. So don't count, I know it's in both categories, but don't count that twice. It's like an overlap. So out of that, there would be 3 out of 6 possible things that you would have on a cube. So this would just be, probability would be 1/2 there. So I said 3 or a number less than 4. 3 falls into both of those categories. You don't want to count it twice. Okay. I'm going to write a little note on this one. This is a variation here. Don't forget to put a K in this problem. Okay, so this says P varies. So I'm going to write P equals. Varies turns into an equal sign. And I'm just going to automatically put a K after that so I don't forget for my constant of variation. It says directly with Q and inversely with R. So a direct relationship is just multiplication with your constant of variation. So we're just going to put the Q right next to the K. And then inversely puts whatever that variable is in the bottom underneath the K. You're going to divide your constant of variation by that. then they're going to give us just enough information to figure out what that K value is. So we're going to go through here and sub these in. It says write an equation of the variation, you know, when P is 12, so I'm going to put 12. We're going to solve for K here. Q is 6 and R is 3. So I'm just subbing those numbers into kind of what I set up to get the K value. I would multiply, or there's a couple ways you could do this. If you want to actually reduce that real quick, 6 divided by 3 is just 2. And so all I would have to do to get the K value is take 12 and divide it by 2. So my K value is going to be 6. All right, so a general equation then here would be P equals 6Q divided by R. That would be a general equation. They always give like a secondary question after you find your K value, which is what you're going to have here. It says use your equation to find P when Q is 18 and R is 6. So the key is you have to get the K value, and then we should be able to do the rest of the question. So P equals, I know K is 6, Q we're going to sub in 18, and R we're going to sub in 6. And if you want, we can just cross those 6's off right there. P should be 18 to answer that question. So this is going to be my answer. Just don't forget the K value. People always forget that. And we're going to do 2 more problems, and then I'm going to be quiet. Okay, this is similar to one we did on the front, where we did an exponential into a log, so this is a reverse from that. So all you got to do to put this in exponential form, the base of the log, we're going to swing this guy over, push that 2/5 up in the air, that'll get rid of the log. The 4 just stays where it's at. So the 32 swings over here, becomes the base of your exponent. So the 32 becomes like a normal size number and pushes that 2/5 up into being an exponent. That's also a true statement. We're not solving anything. We're just converting between the 2 different formats. All right, and we're going to do one more. And this is actually similar to one we did at the very beginning today. Okay, so this is inverse variation that we're going to graph, rational function, and I've got it squared. All right, so I'm going to do opposite copy. So with the x, we're going to go the opposite way. We think that looks like a +3. So -3 is going to be our vertical asymptote. Whatever is outside the fraction there, you're just going to copy that. That's going to be your y. That's 4. So I have a nice horizontal line at -4. And then the only difference between this and the question we did at the beginning today, this has a -2 on the top. So what that's going to mean is it's squared. So the 2 branches are going to go the same direction. If it's negative, they're both going to go down. It would look like that. All right, so my domain and range here. Now, my domain, you're going to go left and right forever. You hit every number, but you don't take that asymptote in the middle because we can't divide by 0. So I could say all real numbers, but x is not allowed to be -3. If you want to do the interval notation, we would just do -infinity to -3, little union, -3 to infinity. It just excludes that one value. Now, the range here, I always think this is trickier for people. When you do the range has to start with the lowest possible value. I have no graph up here, right? The graph is all below that horizontal asymptote. So the lowest range value there is going to be -infinity. And this would point down forever. I would stop touching the graph at that horizontal asymptote, which is -4. And we're just going to use a parenthesis because we don't actually touch that.